So in this section, we'll talk about software crashes, or software BSOD. For the past 30 years, I've been analyzing crashes. I started out with an operating system called VMS, many of you may know. It was written by an author by the name of Dave Cutler, who went on to write the current version of Windows that we all know and love. So over those last 30 years, I've seen a variety of crashes occur. And so in this section, I'm going to try and identify with you about those crashes and which ones you're likely to see. So as you may know, here's the blue screen of death you may see on your console if your system ever crashes. What you may not know is there's over 250 different types of blue screens of death, or otherwise known as bug checks. Now, the operating system has these hooks embedded throughout the kernel, which try to catch drivers that aren't behaving by the rules, rather than jeopardize the integrity of the operating system. Of all these 250 bug checks, there's less than a dozen that are commonly seen, and those are the ones that we're going to focus in on. Now, these crashes are typically caused by a bad or buggy device driver. As I mentioned, lots of third-party vendors will install their tools on Windows, and a lot of those drivers may not be behaving as they should. So that's why we can typically see a lot of crashes out there after the operating system is released. So I wanted to review for you some of those top software bug checks out there. The first one you've probably all heard of. It's a stop A, which is an IRQL not less or equal. Essentially, this tells us that a driver has tried to touch a page of memory at an elevated IRQL. Now, a good tool or good way to figure out all these different crash types is to bring up the actual debugger, which I'm going to do right here. Now, we always want to run the debugger in administrator mode, so I'm being prompted whether I want to allow it to run or not. So up comes the debugger, you'll see in just a moment, and there's some online help. I'm going to pull up the contents of the online help here, and you can actually drill down into the bug checks or the blue screen. So here's the bug check code reference. So if we expand there and go to the bug check A, a stop A, this indicates that a Microsoft Windows or kernel mode driver has accessed page memory at an elevated IRQL above dispatch level. Now, what's important are the different parameters that are associated with a bug check. So not only do you get a stop code of A, you'll get typically 4 arguments. So in this case, the first argument describes for us the memory that was referenced. The second argument tells us the IRQL, or the interrupt level, at the time of the reference. And parameter 3 tells us whether it was a read or a write. And finally, parameter 4 tells us the address which referenced the memory. This is the important part, which device driver potentially referenced that memory. So what I'm getting at here is the debugger offers a great help file. It's one of the best help files of all the tools I know that Microsoft produces. Not only does it give you a description of the bug check, it also gives you potential cause of the bug check. You can read here as well as I. Or it also gives you the resolution, how you go about troubleshooting this. So I highly recommend starting out with the debugger's online help to get you started on analyzing your crashes. So, in addition to the stop A, we have the stop 50 bug check, which is a page fault in non-paged area. Essentially, anytime a device driver needs to reference a page of memory, it needs to be locked down in non-paged area. And this bug check happens when we experience a page fault and we have to go out to disk to get a page of memory that should already be locked down. So the system won't allow this, so that's why that particular stop code occurs. Somewhat similar is the stop D1. This is a driver IRQL not less or equal. Once again, we've got a driver trying to access pageable memory at an elevated IRQL. Here we have a stop 3B, which is a system service exception. So some process was executing in non-privileged user mode and executed a system service which, because of the arguments or something, caused it to fail in kernel mode. So that's why the system crashed. There's also something known as a stop 9E, which is a user mode health monitor type bug check. This is typically seen with the cluster service in that if it is not receiving response in a timely fashion, it figures that something is definitely wrong with the cluster and will cause the system to crash. Finally, there's a stop E1 bug check, which is a worker thread returned at bad IRQL. Once again, we have a device driver that's trying to do some work on an I/O, and it encounters a problem. So that rather than continue, the operating system will bug check the system. So to start out your analysis, there's several things you want to do. As I've already mentioned, you want to always leverage that bug check code reference in your online help. That will help you to look up the particular type of bug check or stop code you're experiencing and see what the different arguments may mean, and also what is your pursuit of action, whether you should back off the device driver, upgrade some firmware. The online help is very helpful, so I always recommend you utilize that. The next thing to do is begin your analysis with the command bang analyze-v. This should always be your first debugger command because it does a automated analysis and may actually figure out what caused the system to fail. It'll certainly point you in the right direction by giving you other commands to issue to leverage you on your way. Then there's a handful of debugger commands that you'll find yourself using quite a bit, like the bang thread to take a look at the thread that was currently executing at the time of the crash, kv to show you your stack backtrace, in other words, what led up to the crash. You can then take a look at the driver that was involved with the bang lmi command or the lmvm command. Then you can look at all the installed drivers with the lmtn command. So there's a few commands to get you going.